got into a little bit of one of our digressions late last week about all the different ways you can solve exponential equations. The first and most simple way that you would teach kids in Algebra 1, because they don't know logs yet, would be this first example where you've got the capability of writing both sides with the same base. Okay? Because you don't know logs in Algebra 1, this is really the only conceptual way we can teach. We would change the 9 to 3 squared, and we would change this to 3 to the negative 1/3 from your, what you know about radicals and exponent rules, getting something out of the denominator. And then following your exponent rules, this has an exponent of 2x. And so once your bases are the same, you can drop them, and you get 2x equals negative 1/3 and solve. Divide by 2, x equals negative 1/6. So the common base rule, over here with your base of e, same thing. The right side is the same as e to the negative 2x. Set your exponents equal. And then solve, so subtract x from both sides and divide by negative 3. Okay, and that's pretty much where you'd have to end with Algebra 1, kids. On the next set, obviously, you can't get a common base on both sides. 8.07 isn't conducive to 10. 137 isn't conducive to 5. So you definitely are going to need your calculators, because we don't know the logs of most numbers in our head. So here's what we kind of talked about in our digression the other day. It wasn't a digression, it was a progression, by the way. We progressed to new knowledge. You can take the log base 10 of both sides. You can take, well, in this case it's the same, the regular old log of both sides, which is the log of base 10. Or you can take the natural log of both sides. Okay? You can do anything, any one of those that you want. So if I just think what you did last year, and this one's a little funny because a plain log is log base 10 anyway. But we take log base 10 of the 10 to the x power, so that will just cancel. And then we get x equals log base 10 of 8.07. A lot of these, all of these on your test will still be non-calculator. Your answers are just going to be written in this log format. Okay? So if it was a multiple choice, this would be an option, or because it's log base 10, it would just be log of 8.07. Okay? Does that make sense? The other possibility, and I'll just erase this and redo it and you can just watch, would be to take the natural log of both sides. So then it's x, you'd bring that variable x out in front, x times the natural log of 10 equals the natural log of 8.07, and then you divide the natural log of 10 over. And if they are giving answers in terms of natural logs, then they, on a multiple choice, then you have to know the way of doing it using the natural log. Does this make sense? Okay. Now on this next one, I'll truly show you the 3 different possibilities. I'm just rewriting it twice. So on the one hand, like I said, what most of you probably did last year was took log base 5 on both sides. So log base 5, log base 5. You'd bring that just cancels, so it's x minus 3 equals log base 5 of 137. And then you add 3 over. So x equals log base 5 of 137 plus 3. You could also, and again, depending on the problem, one of these methods is not always the most efficient. But you could just take the natural log of both sides. And then that would be x minus 3 times the natural log of 5 equals the natural log of 137. divide over the natural log of 5. And then add your 3. Stephen? Let me do all 3 of these, and I'm going to answer your question and show you kind of why these are all the same solution, even though the presentation is different. And then on the third one, if you don't do the natural log, you just would do the plain old log. Again, and technically we all know that's log of base 10, but we would bring our x minus 3 out in front still. Log 5 equals log 137. Divide your log 5 over. And add your 3. And all of these would give you the same answer on your calculator. The fact of the matter is, no matter what way you do it, you have to take the same type of log on both sides, whether it was the log base 5 on both sides, or the natural log, so log base e on both sides, or log base 10 on both sides. You could take the log base 152 on both sides, as long as it's the same log. But the reason these kind of two developed kind of ties in with what we talked about with the change of base formula on Thursday or Friday. Back in the day, you didn't used to be able to type that in on your calculator. Log base 5 of 137. So I'm pretty sure that's why I was never ever even taught that way, because if you had to type in log base 5 of 137, you would have to change that via the change of base formula anyway. And this, using the change of base formula, is the same thing as log of 137 divided by log of 5. Or natural log of 137 divided by the log of 5. So you can see from the change of base formula, whether you do the change of base formulas with natural logs or regular logs, it's the same either way. Do you see how all 3 of these are equivalent due to that change of base formula? Did that answer your question? What was your question again? Like, why the multiple methods? Right. Because back in the day, we used to avoid the fact that our calculator can't do that. And we kind of got in front of it and did it this way. And then we didn't have to worry about the change of base formula. It kind of took care of itself. Versus here, I could have learned it this way, but then I would have always had to have changed that when I typed it into my calculator using the change of base formula, which is no big deal. Oh yeah, it is, but the way the multiple choices are written, you've got to pick the way that they wrote the question. So you need to understand the link between all 3 of these. Does that make sense? Okay. On this one, the most efficient way is 100% to take the natural log of both sides, right? You know that when you're getting E all by itself. So taking the natural log of both sides is definitely the fastest way. So that cancels. You just have 1 minus 8x equals the natural log of 7957. And then solve for x. So subtract your 1 over. And divide by negative 8. Now, if you were to type something like this into your calculator, just be careful, because when I hit the natural log button, my calculator is opening its own set of parentheses. So I need to make sure I put 7957 in there and then close it. We're not taking the natural log of the minus 1. We are not turning 7957 minus 1 into 7956. If that were the intention, we would have had parentheses around there. But obviously, this is happening first. And then we're subtracting 1 after the fact. So just make sure you're careful of that, and you're not tempted to combine 7957 minus 1. Okay. On this one with a negative in the denominator, you may see 1 minus the natural log of 7957 all over positive 8. Are we all good with that being the same thing? Okay, so just, yeah, Stephen. I could take the log of both sides. I wouldn't. Because if you look at these two ways, it's really doing this way and this way. They kind of, luckily, end up being the same thing. Because which of these three ways is your favorite way? Log base 5. So you would do log base e of both sides. Well, that's the same. That's what ln is. So that's hitting two birds with one stone. That's like, you can't really tell me which of these methods you chose on that one because they're the same thing, regardless of which one you mentally think you're doing. It could be, it probably would not be in the case of an E. It could be, it probably would not be. Because it's just, this one is a no-brainer as to what's the most efficient way. This one, not necessarily. Okay? Now, the whole log base 7 or log base 3 on this one is trickier because neither is going to be overly efficient, right? Either way you do it, on one side, you're going to have something not so great. So why don't we do this? I want to do a little experiment. I'm going to argue that there's 4 ways of doing this one, and I'm going to assign each of you 4 ways. I want all of you 5 over there to take log base 7 of both sides. I want Kendall's row to log base 3 of both sides. I want you guys to just do the natural log of both sides. And I want you guys to do, well, I want you guys to do this plain old log of both sides. And log of 10. Log of both sides. And you both pick whatever you want. And then I want everyone, to, whatever you do get, round your answer to the nearest 10th, I guess, just to make sure we're all on the same page. How's it working? Not great? All right, let me take... doing all four methods. Some of these might not be great ways, and we can just kind of learn why they're not great ways without me having to do it out. But here is a natural log person. They took the natural log of both sides, brought their 2x plus 1 out in front. Now, what don't I like about the way they wrote this? No, I'm fine with those parentheses. But I need there to be parentheses around the 2x plus 1, right? Not that necessarily they screwed up because of it, but technically what they have is 2x plus, only their 1 is being multiplied by the natural log of 7. So they probably, I didn't even look forward to see if that affected them. But when your exponent is a binomial, keep it in parentheses. So they brought both of those out in front. And then they divided the natural log of 7 over and divided their x plus 2 over, and then we're in a bit of a pickle because how are you going to solve for x? You can't solve for x unless you get all your x's together, right? Yes? So if they just cross multiply, they're going to be back up here. Does that make sense? So unfortunately, what we have to do that we may not like doing is we have to get these two x terms together, which means we have to distribute. So it's 2x times the natural log of 7 plus the natural log of 7 equals, same thing on this side, it's x times the natural log of 3 plus 2 times the natural log of 3. Now, because we've got 4 distinct terms, we can subtract and get all of our x terms over on the left and subtract the constants, so subtract the natural log of 7 over to the right. So on the right-hand side, we have 2 times the natural log of 3 minus the natural log of 7. On the left-hand side, can we combine these? If you can't combine them, factor them. This is 2x ln of 7 minus x ln of 3. Factor out an x, and you're left with 2 ln of 7 minus ln of 3. Now I can get x all by itself just by dividing this over. So x equals that. Okay, so that's, unfortunately, none of these are going to be pretty. They're all going to be ugly to a certain extent. I'm tempted to say that, whose was this? Can you pass that back to Josh, please? I'm tempted to say that log base 3 or the log base 7 on both sides will be the most efficient, but let's look at the log base 7 method. So log base 7 on both sides cancels that, so we just have 2x plus 1 equals log base 7 of 3 to the x plus 2. She brought her x plus 2 out in front, and she kept parentheses around it like a nice little girl. Yeah, you did. They were there. Oh, yeah, you need them. Oh, I saw them there, so you had them there and then erased them? Oh, I thought you just wrote them. Okay, so, again, we have to get all of our x's together. So she subtracted this x over and kind of separated it from that, which is why not having it in parentheses affected her. But again, you have to distribute. So it'll be 2x plus 1, no problem on the left. On the right, you have to distribute, so it's x log base 7 of 3 plus 2 log base 7 of 3. Get all your x terms over, so subtract that over. 2x minus x log base 7 of 3 equals, and take this plus 1 and subtract it over, so it'll be 2 log base 7 of 3 minus 1. Then, if you can't combine them, factor out your x. And then divide that over. So x equals 2 log base 7 of 3 minus 1 over 2 minus log base 7 of 3. Is that the same looking answer as our other one? But similar? What read yours again, Josh? Okay, so it does kind of look, I'm sure, I know it's the same. If you type this into your calculator and get a decimal and type Josh's in, they will definitely be the same. how we would have to manipulate and prove that they're equal. Otherwise, it's a different story. But does that make sense? The log base 3 method is going to be very similar. Can you pass that back to Taylor, please?
Nice.
That's okay. The log base 3 method is going to be the same. And how come I don't have a log base 10 method? Or did I already do that? Was that yours? But it should be the same, right? It's all about keeping parentheses around that binomial exponent and distributing, which is not pretty, but it's a must when you have two different bases, both with exponents. Okay? Flip over to the back. Okay, so you're going to run into problems like this, and we'll just look at this one first. It looks crazier than it is. It's just factoring. You're just, what multiplies by what to give you e to the 2x power? Right, e to the x times e to the x. So if you're guessing and checking, e to the x and e to the x give you e to the 2x. And then you got to multiply to get negative 12, so positive 4 minus 3, so that your outer 4e to the x and your inner negative 3 to the x combine to be 1e to the x. Okay? And then we just tee it up. On the left one, we're just going to add 3 to both sides, and on my right one, we're going to subtract 4 from both sides. And in both cases, it's just e to the x, so it's very straightforward. Just take the natural log of both sides. Which one is that going to give you trouble on? Because you can only take the log of positive numbers. So this answer, the natural log of negative 4, doesn't exist, so that doesn't give you anything. But your only solution is the natural log of 3. Okay? And then there's my other one. It's just e to the 4x. So I made it e to the 2x. But the same thing is going to happen. You can just look at it. You don't have to copy everything down. Just process it. Just guessing and checking, just like you would do with x to the 4th power. You would do x squared and x squared. You do e to the 2x, e to the 2x. And then when you get e to the 2x equals a negative number, taking the natural log of a negative just gets rid of that answer. Oh, gosh. You have post-traumatic stress disorder?